Hello and welcome back to Coinscrum's Meet the Founders. I'm thrilled to be joined today by Wang, who's a co-founder at Crust Network.
Hi, Paul. Thanks, everybody. Yeah, this is Leo. Nice to see you guys.
Right, so before we dive in and talk about the Crust Network and find out more what about you guys have been doing and building, we'd like to find out a little bit about the background of our founders. What were you doing before you entered the world of crypto and blockchain development?
Sure. So actually, I can do a very simple introduction of my background. So I've actually working in this industry, IT industry, for over 15 years now. So previously, I was working in Microsoft on the development tools and platforms, including Visual Studio and other things like .NET language, things like that. And later on, I worked in Cisco on manufacturing cloud and data systems. So it's basically like a distributed data system. It manages all the manufacturing's data and business processes over 200 geographic locations. So, well, basically, I've been doing technical work for quite a long time. So that's my basic background. And for the crypto part, I think that's like 5 years ago. I think it's 2015. So as I mentioned, I was working on the manufacturing data cloud system. So one goal of the system is to record the component traceability data out of the production lines in the factories, right? And then record it and share the data with all the suppliers over all the world. So that is the scenario. Actually, the data is pretty big and needs to be shared across lots of companies. So that's when we noticed Ethereum at that time, and we launched a prototype project to try to use smart contract to record all the key information on the chain. So that's like how I got into crypto world. So after that, actually, I launched actually participated in another project to try to record the education videos, online education videos on the IPFS public network. So I tried that, and right now it's running in a commercial online education system, but it's not like a public chain, or it's more like a consortium chain. So that's my background on the crypto.
Right. Okay. Thanks for that. And my next question was going to be what inspired you to look at decentralized storage, and when you decided to set up the Crust. But I think you've probably answered that question, because it seems like that was an area that you were already focusing on in terms of data and sharing information. So I guess that was a natural progression, and that inspired the ideas of how you do that on public networks.
Right. So yeah, as you just mentioned, decentralized and distributed data, or file storage, is always a very big field, no matter it's in the traditional IT world or crypto world. So, especially when people talk about Web3, it's pretty common issue, right? So I paid a lot of attention on this area, including all the Ethereum-based solutions and also the IPFS as the data protocol. So that's why I launched this project. Yeah.
Cool. And so before we just come on, I guess, looking at the product itself, what about the rest of your team? Can you just tell us a bit more how you kind of brought the team together? Who else is involved with the project?
Sure. Yeah, I got several partners like Bova. You can always go to our website to find all the information, but I can do a short introduction here. Like Bova, who has a very strong background on the traditional financing and crypto. He is actually leading the overall project strategy and also the economic model design. So that's for him. And then Zikun, who is our CTO, he was working in Microsoft on cloud computing as well. And now he is leading our technologies. And also Steve, he is actually previously working in Cisco and now running our marketing activities. So other than that, there are a bunch of other good people in our team. Yeah.
Excellent. So let's dive into the product now. So I know when we spoke before the call that you took into we discussed how there's a few other projects and networks that have already established themselves looking at this same trying to address this same problem for decentralized storage. We had early projects like Storage and Sire. More recently, Filecoin launched last year, again focusing around building around IPFS. So can you tell us a little bit more just about a high level, a product overview, what it is you're building, and a little bit how they might, your solution might compare to some of these other projects, but also, what you see as unique to Crust.
Okay. So I think I can give you a overall introduction here. So Crust, as you just mentioned, is a decentralized storage network within Web 3.0 ecosystem, and we actually built our technology stack based on the substrate framework, which is the same framework that Polkadot and Kusama uses. So essentially, from a user perspective, the goal of Crust is to provide an easy interface of the storage market for users to use. So people just need to go to there, put the files on IPFS, and place a storage order on Crust chain. Then the files will be stored and distributed in the Crust network. So that's how it works. So after that, people should be able to access the files from everywhere through the standard IPFS gateway and interfaces. So there are plenty of those nowadays, right? So from a miner, that's actually from the user perspective, and from miner perspective or resource provider perspective, miners should be able to run Crust node programs on our website. It's already open source on their servers to provide their storage resource. And in return, they will get the incentive from the network and the storage market. It's totally decentralized. There's no super nodes or anything like that. Yeah. So that is like a overall description of our network. And for the recent progress, like recently we have launched our preview network. We call it the Maxwell, and you should be able to see the Maxwell, all the statistics and data from some of the portals like the telemetry and also other blockchain explorer, right? So it's basically an incentivized network. And I think right now there are more than 1,000 nodes joined in. So we have pretty much rolled out most of the key features on the preview network Maxwell, including all the DSM, the decentralized storage market and the POS consensus and also the MPOW storage proof mechanism. So that is our current progress. And also, you just point out other projects, for example, Filecoin, and there are a lot of like Storage, Saya, and Arweave. So there are plenty of those. But across the network, from a use case point of view, we are all serve a purpose like to provide a decentralized storage network, but it's not 100% the same. There are some of the key differences here.
Well, we're going to talk about a bit more about the four core components of the Crust network. So we'll come on to those, and maybe we can then identify some of those differences as we go through. Before we do that, you mentioned at the beginning that before you set up, you founded Crust, you've been working on a private version of Ethereum for an enterprise use case. So you got to understand that technology well and its limitations, I guess. At the moment, we're seeing a big race for potential challenges to Ethereum with projects such as Cardano and Tezos and Avalanche now. And Polkadot has been getting a lot of traction, obviously, recently. We're seeing lots of projects choosing to build on it. Can you just tell us why you made that choice? Did you look at other options as well, and why you decided to build on Polkadot?
Sure. So talking about the technology selection here, so let me start it from here. So actually, after we finished the overall design of the Crust network protocols, actually we started from the design of the protocols itself. So including everything like the DSM, GPOS, and POW kind of stuff. So we made several technical choices here. So first of all, we need a platform to implement those protocols, right? So that is the first question. So there are a couple of choices. We can like either choose a smart contract platform like Ethereum, and we can implement our protocols using smart contract mechanism, right? Or maybe we can choose to build our own chain and implement our protocols as layer 1 modules instead of a smart contract, right? And we ended up finally chose Polkadot platform or ecosystem because it provides much higher performance and flexibility. So it fits our needs because Crust is relatively, complicated and requires much high performance. And also, instead of running a total separated public chain, Polkadot's parachain mechanism provides much better interoperability. Mm-hmm. And it's very important for Crust because we aim to provide a general storage infrastructure that can be leveraged by a lot of DApps, right? So that is the first choice we made. And then secondly, after we chose the platform to implement our protocol, we definitely need to choose like a distributed file system, or maybe we can call it like a data exchange protocol. So there are plenty of those, some of them from traditional internet world and some of them from the crypto world. But I mean, IPFS is definitely one of the most outstanding one, right? Compared to like other technologies, right now it shows wider adoption, especially within the crypto world. For example, I think people should be able to see a lot of DApp front end and websites right now are hosted on the IPFS. For example, the Polkadot apps wallet and also Uniswap front end. Those are already hosted on the IPFS. So that's why we made our choice on the Polkadot plus IPFS.
Yeah. Yeah, no, very interesting, and I guess that's similar to these are the decisions that all new projects need to make, and we're still the industry as a whole is still at its very early stages, and future proofing and interoperability is, I guess, one of the or two of the biggest factors that you need to think about when you start the project and make sure that you're going to be around for a long time. So let's go a little bit more into the architecture of the network as a whole. As I said, it's kind of four key components. So maybe we'll work through those. And in terms of like how file storage is managed, and as a decentralized network, how nodes are operated and how consensus is reached. As I understand it, you have a combination of elements of proof of work, but also proof of stake. So could you start with just talking through those two components?
Sure. So before I talk about all the components and modules, I can give you like an overall architecture view here. So basically, overall speaking, Crust works in 3 layers. So we got 3 core layers: MPOW, meaningful proof of work, right? That's one. And then second is the GPOS, guaranteed proof of stake. And the last one is the DSM, Decentralized Storage Market. So each layer actually serves different purposes. So first of all, the MPOW, the goal of MPOW is to generate the storage proof. And internally we call it the storage work report. We also call that in our wiki. And uploads all the work reports onto the chain. So that is the goal of the MPOW. That's pretty straightforward. And then the GPOS, overall speaking, is actually a POS-derived consensus. It's like the core consensus that forms up the chain. So all the work reports and the storage orders will be put on the chain. So that is the GPOS, right? And then the last layer, DSM, actually it's an on-chain module. It's not a layer 2. It's a layer 1 thing. So it basically provides a storage market interfaces. So I mean, one of the most important interface being the storage orders. So essentially, DSM allows users to place storage orders on the chain. So that is the overall view of the 3 layers. So those are like the core layers, and based on this information, I think I can go through all the layers one by one, right? I mean, from the MPOW and GPOS. So first of all, for the MPOW, MPOW essentially like it plays like a work inspector within the TEE environment on the Crust node. So what is the TEE? You can think about like it's more like a safe box in the CPU area, and nobody can enter that and tamper the data or get all the information. It's like a secure safe box, right? And the biggest component within the MPOW is the work inspector. It's a core module there. So basically, whenever a file is stored on the node, the file will be sealed, and then the storage information will be generated, and the storage information will be passed to the TE, to the work inspector, and the work inspector is going to recognize and store the information within the TE memory. So that is the first step. And then later, like on a regular time basis, right now, I think in the preview network, we have set it to be every half an hour. So the work inspector will read the storage info in the TE environment, and then it will go to check if those files really exist on the disk. So this is actually done via Merkle root hash check. So that is like a check process. And after that check, the work inspector will generate a work report to include what files are actually stored on this node and what files are actually lost. So that is the final information. So the information will be included in the work report, and the work inspector is going to sign the work report within the TE. And then once it got the work report, it will send it over to the chain. So later, like every node, the network will be able to verify the signature from the work inspector to ensure it's valid, it's not forged or tampered from any place from at any time. I think we mentioned like the zero knowledge, the ZK proof mechanism or the algorithm in one of our papers. So ZK is essentially another approach to generate such work report. But I mean, from a purpose point of view, it serves the same purpose, just to generate the work proof, right? So the difference here is in the ZK algorithm, it will generate a ZK proof, not the TE signature. That is the key difference, but rest part are pretty much the same. So, I mean, that's how the MPOW module works. That's for the first layer. And then the second layer, GPOS, this one is actually easier to understand. So the GPOS is basically like a MPOS that Polkadot uses. It's just a MPOS with staking quota. So basically, within GPOS consensus, users can, they can vote to specific nodes to do their staking. And then the difference here is that each node actually has its own staking quota. The quota is actually decided by the storage resource it provides. So for example, let's say if a node has provided 1 terabytes worth of space, right? And according to our equation, it should be able to stake up to 1 CRU. So that is the Maxwell. And this quota actually can be impacted by several factors. Like for example, if you store files from storage orders and the files got more copies on the network, then the staking quota can be calculated in a different way. But in general, it works like that. So I think you can always go to our wiki or to see our white paper for more detailed parameters. Yeah, that's how the first 2 layers works.
Okay, just before we come on to the DSM and the marketplace. So if people want to obviously contribute to the network and earn rewards for contributing to the network, I guess it's probably quite clear at the proof of stake level. On the proof of work side, what does it take for someone to contribute? Do they need dedicated hardware, or is it, if you designed it so it can be, all of these things can be run on relatively standard hardware? And how are contributors rewarded at that layer as well?
Right. So as I just mentioned, so because we built our MPOW layer based on the TE technologies, right? So with standard servers or PCs, you should be able to join as long as the CPU supports the TE, right? And I think right now the TE technology is pretty, it actually has a wider adoption. Like for example, for most of the servers and PC of Intel CPU, you should be able to use it directly. Like it's kind of like a built-in thing. But right now we have only supported the Intel, but along with our roadmap, we definitely want to support other CPU types for sure. So that is from a hardware perspective. And as I just mentioned, for the MPOW, once you got the right hardware configuration to be able to join the network, then the proof of the POW perspective is that once you provide the storage resource, then the work will be measured and included in the work report, and that will give you like a staking quota. And so it's like it's not like immediate incentive based on the work. It's still be done based on the staking, right? It's just
right. I see. You're earning your quota. You're proving your proving your resource to earn your quota for staking.
Right.
Okay, well, great. Then let's move on to the next component, which is the decentralized storage market, the DSM. Tell us more about that.
Sure. So DSM essentially allows users to place storage orders on the chain in layer 1. And once the storage order is placed, the storage fee will be split into like 2 parts. So the first part is actually directly paid out to the nodes who get the files first. So that means, for example, those nodes are better quality network, or maybe they are closer to users, right? So that is the first important one. And then the other part of the storage fee will be added directly to the staking pool. So that means they will be paid out to nodes while standard GPOS process, right? While staking. So that is how the payout works. So that's actually payout to the storage orders. And on the other hand is the retrieval process, right? So the retrieval actually is not directly rewarded in Crust Network. So we basically reward the retrieval by encouraging the nodes to share their files to others. For example, once the node does that, and a file got more copies on the network, so nodes whoever have that file will have a significant growth in the staking quota. So for example, let's say if you got one file that is 1 gigabytes, so normally you should be able to stake, let's say 0.1 CRU, that is the staking quota. And then if the files get, let's say 40 copies over the network, then you should be able to get like 0.4 CRU. So that is the staking power or staking quota reward. So that is how retrieval is rewarded. So overall speaking, from a user perspective, if user want to use the DSM, right? So he just needs to follow like 3 steps. So first of all, he needs to upload the file onto the standard IPFS public network, right? So that's one. This is permissionless, right? That's one. And then secondly is in the first step, you will get a CID generated by the IPFS. You will be able to get that. And then go to the Crust network and place a storage order to include the CID. And that is step 2. So after that, wait a while until some of the Crust nodes pick up that file and store it and generate the MPOW proof. Then you should be able to see that over on the chain, via many other interfaces like the Crust apps, right? So that's basically the step 2. So after that, then you should be able to access all the your files via standard IPFS gateway and interface. Yeah.
Right. Okay.
That is how it works. Yeah.
Yeah. And so I guess with that solves the problem that a user would effectively pay once to store, and it doesn't matter how long they're storing those files or when they go to retrieve them. If they retrieve them tomorrow or if they retrieve them in 5 years' time, the cost of retrieval is free to the user. And the node operators have been incentivized up front to make sure that the files, well, the location of the files effectively has been shared across the network.
Yes, right.
Okay, cool. And then the final part, I guess, which I guess is more on the front end side, but is a critical thing because, as we all know, user experience is one of the big challenges across the blockchain industry, and things are getting better. You've got your end user storage application. Can you just talk about that and just talk about the user experience, how important that is in your design, and what that experience looks like to someone coming, especially if they're not, a crypto native person, but's interested in using the application and wants it to work just like their Dropbox or, G Drive might now. Can you tell us more about that?
Sure. So right now we have published one application called Crust Apps, right? And actually, this Crust Apps, we call it Apps Wallet, is built based on Polkadot's Apps Wallet. So it's a decentralized. So in terms of the user experience, it's not like very good, but it's usable. So the intention of our first application is to provide a usable interface. That's one. And then the second purpose is to open source that so that developers should be able to see the code and build their own application. So that is the goal of our first application. Mm-hmm. So for this Crust apps, we basically integrated all the IPFS functions and GUI within that UI interface.
Right.
So if you go to IPFS tab of Crust apps, you should be able to perform any operations of IPFS and interact with the local IPFS node. So that is the overall description. And so from a user perspective, a normal process to use that is to go to IPFS tab, and you can do like a drag drop, or maybe you click a button and select a file or folder. Basically, uploading a file or a folder to the IPFS tab. And then you should be able to go to you should be able to click the icon right next to the file. There's a place storage order, so click that and place the storage order and pay out all the CRU, and the files will be stored. So that is the user flow. But from a non-crypto world, people we don't want to enforce everybody, especially for end users, to buy tokens. Mm-hmm. Yeah. So. Well, but that's not the target user of the Crust apps, as I explained in the beginning. So basically, we have already open sourced the Crust apps and also the Crust SDK. The first version of the Crust SDK is ready now, and it's on the GitHub. And we basically encourage more developers to join and build more user-friendly applications. So those applications will deal with a lot of user experience flows, like for example to exchange currency and things like that. Yeah. I think half a year ago we have published another application called Crust Cloud. Recently we are organizing and cleaning all the code, and that will be our second or next application we are going to publish as a reference sample to the whole community. So that one is more like a user friendly. Because it's not 100% decentralized. It's not like the Crust apps. Yeah. Right.
Okay. Well, that's a good thing though. That anyone can come in, start building, and be inspired what you have on the base layer, so to speak. So, where are you at now on your roadmap? What state's the network at? You have a test net out there. What's coming up over the next 6 months?
Over the 6 months. Okay, so right now we are actually at the open testnet phase. So if you go to our website and see our roadmap, after that we are going to be the mainnet launch. So that's a big milestone. But before that, there are actually two milestones in next 1 or 2 months. So first of all, we are going to release more like a detailed documents on our program interface and SDK and use cases for developers. So accordingly, we are going to launch a plan called the Crust Grants. So basically, we want to encourage and incentivize developers to develop more applications based on Crust Network. That's what we discussed just now. So that's a big thing. And right now we are designing the stack and the grant amount and things like that. So hopefully we can publish that in like 1.5 months or so. Yeah, so that's one. And then secondly, we are also preparing for the parachain slot auction. I think a lot of Polkadot ecosystem projects, they are preparing for that as well. So because that's definitely a big thing for all the projects within the Polkadot ecosystem, right? So, because the details of the auction is not released by Web3 Foundation, so we cannot say the concrete marketing plan. It's not finalized, but what we can see right now for marketing is we are preparing for that. So that's for that. But technical wise, we are going to adapt our chain implementation to fit parachain standard. And actually right now, I think we have published the information that we are already connected into Rococo parachain testnet, right? So basically we fit the Rococo parachain testnet standard, but still we are closely following up with the current parachain progress, because there might be some of the upgrades and changes. So definitely we want to adopt all that and prepare us with all the technical solutions. So that is the like the 2 milestone within the next few months. And after that, we are going to prepare for the mainnet launch, but still that depends on the parachain slot auction. So we cannot say a concrete date. Yeah.
Yeah, that was going to be a question. As I said, you know, lots of, including yourselves, lots of people obviously positioning themselves to build around the Polkadot ecosystem. But I guess a challenge there is that they're still rolling out gradually over time. So they have new features and functionality which will be emerging, which are you finding yourself limited by that at the moment? And are you having just to obviously be patient and to let them do their work and their upgrades? And if whether it's holding you back or not, if they hit their own milestones, is this going to open up a lot more opportunity and enable more functionality for you?
Well, I mean, from a parachain point of view, definitely we got several dependencies, because even for Parity and Web3 Foundation, the parachain technical stack are being improved, and you know, they are quite actively develop the whole thing. So that is definitely one dependency from a parachain perspective. But the good news is that for the Crust network protocol themselves, like for example, the MQW, the GPOS, the DSM, those are controllable by ourselves, right? So that means even without the parachain mechanism, we should be able to launch our network without any problem. So the major consideration from our standpoint of view is that if we launch the mainnet, like maybe right now or very fast, there's a potential risk, like maybe we need to do a hard fork to fit the parachain technical standard. So that is the only dependency. So that's why we are closely following up with the technical standard of the parachain, but that is the only dependency. Other than that, we are pretty much settled with ourselves.
Yeah, excellent. Well, look, this has been, we're just conscious of time here, and it's been a fantastic overview of the project. Before we go and say goodbye, I guess we're based over in the UK, you're over in China, so much activity across the world. What is the state of the whole crypto and blockchain ecosystem in China, and what's adoption looking like, and how much activity is going on?
Okay, yeah, I would say, I think from my perspective, it's pretty well adopted in China, overall speaking, crypto world. So we can tell that actually from a lot of perspectives. So for example, in China, I think we can see the BTC mining farms like running, very large scale mining farm running. I think data from last year was more than 50% of mining power of BTC was in China, right? So that's one. That's one perspective from mining. And then if we look at the Chinese companies in the industry, from the, like the internet companies and IT companies, so we can see a lot of those companies that they actually developed their consortium chain in different use cases. Right. So for example, the supply chain financial, because in China, we got a very big base of the manufacturing factories all over the places, right? So supply chain financial, and component traceability, logistic. So those things are, we can always say there are some of the consortium chain launched based on that purpose, right? So that's another perspective. And also there are also integrated public chain service providers, like I think one called BSN, Blockchain Service Network. So it's essentially to provide a service interfaces to public chain platforms, including Ethereum and Polkadot, right? So I think overall, I would say it's pretty positive, and the adoption is becoming bigger and bigger. Yeah.
And I guess one of the big news from last year that people were definitely keeping an eye on was the launch of the digital Yuan that the government's rolled out. Do you have any insights on that, how that rollout's going?
Yes, yes. So there are two perspectives for that event, right? For this technology. So it's called DCEP, DCEP. And first of all, we actually, because the government has actually not published if the DCEP is actually implemented based on blockchain or not.
Right.
It is likely to be, but it's not 100% published and guaranteed. So we are not very sure about that. But definitely blockchain, even if right now it's not blockchain, it will be blockchain like in the near future. That's for sure. So that's one. And secondly, I think starting from this year, people are starting receiving a lot of activities and events around the DCEP launch. For example, there could be like a red envelope from different applications and platforms to distribute the DCEP.
Okay.
To encourage people to use that, yeah. And we can see some of the adoption from some of the officers in the government. They start receive part of their payment check using the DCEP. So that's really? Definitely one thing. Yes, that's actually. I think there's a park, public running by government within, because I'm in Shanghai and there's a city called Suzhou. They got a public park, and some of the people, I mean, the people there, they got the paycheck. They got their paycheck using the DCEP. Yeah, that's pretty amazing. Yeah.
Yeah. Well, like I said, I mean, that's a separate debate altogether, but I think overall it's a net positive for everyone. And it's certainly in the West, I think, woken other central banks and governments up to maybe fast track their own experimentations with their own central bank digital currency. So we'll see how that all evolves. But look, Leo, it's been fascinating speaking to you today. Great to hear about the project, and exciting to hear where you're at in terms of testnet and moving towards mainnet later in the year. So wishing you and the team every success with the project, and we'll certainly keep an eye on how your progress goes.
Okay. Yeah. Thanks a lot. Thanks a lot for your time, Paul.
Thanks.
Yeah.
Bye-bye.